Steel must last. It's the foundation of our industry and of modern society. Production errors can cause weak spots, including cracks, especially when steel is recycled.
Defects in the metals industry are dangerous and costly. In order to discover the cause of a defect quickly, we use metallography solutions from ZEISS.
The SPC Materials Laboratory specializes in identifying the causes of material defects for leading steel producers.
Components are becoming much more complex due to the increasing requirements. Falling margins, a shortage of raw materials, and the use of recycled materials are creating challenges for our customers.
For example, if a prominent crack appears on an engine part during production.
The manufacturer of this pinion shaft needs us to urgently find the cause of this damage so they don't fall behind schedule, which would be very costly.
First, laboratory manager Thomas Schaub documents the crack.
At first glance, it looks as if the damage was caused by a small surface defect during the hardening process. Let's take a closer look at why that has happened.
Next, a fragment of the pinion shaft is cut using this machine.
Here's the fragment.
On the surface of the fracture, I can see a discoloration right where the central drilling took place. I need to look at that more closely.
He uses the digital microscope, ZEISS Smart Zoom 5.
In this enlargement, I can very clearly see scaling on the surface of the fracture. This is a clear indication that it had been damaged beforehand. The defect then oxidized at a high temperature, which caused the damage to spread.
To analyze this further, a sample must be produced. The polished surface of the sample is etched with acid.
The etching process creates chemical reactions. It allows us to see the inner structure of the sample under the light microscope.
The ZEISS Axioimager light microscope produces high-resolution images. This step is particularly advisable when recycled steel scrap has been used.
You can see these bright lines very clearly. They're definitely segregations. This image proves to me that there are segregations where the axle was drilled. They occurred during the steel production. And I can see non-metallic inclusions that make the material very brittle. So if you drill right here to create an axle, I can imagine that cracks could occur.
With the help of the ZEISS EVO scanning electron microscope, Mr. Schaub can now detect the material the inclusions are made of.
Using the sample, I want to examine which chemical elements the non-metallic inclusions consist of.
For this purpose, the EVO is equipped with an EDX detector for energy dispersive X-ray analysis.
We can now see high levels of manganese inclusions where the hole for the axle was drilled. There are isolated manganese sulfides, which make the material brittle. And here we have manganese inclusions as well. We can see how rough the surface of the drill hole is. This combination makes it easier for cracks to form. The cracks expand during the heat treatment process until they break completely during quenching. At the start, I thought a classic surface defect had caused the damage. But by combining the various ZEISS solutions, I now know that a weakness in the material is the cause. By combining microscopy and metallographic solutions from ZEISS, we were able to present our customers with a root cause analysis very quickly. Now our customer has all the information at hand to avoid such damage in the future.